The paper presents several activities that I developed using paper interfaces, which is the merging of paper, so regular paper that you can write on, that you can cut, that you can throw away, that you can photocopy and print easily, with computers. So computers bring dynamic displays like animations, videos. They also bring computations if you want to compute things. And I presented several activities that we developed in the context of primary school geometry, because it's a field where we can really exploit the possibilities of paper very easily. So first, paper, you can move it with your hand, you can do translation, rotation, so that's important in geometry, of course, but it goes also further. If you fold it, it will give you symmetry. If you cut, it's a good way, for example, to explain how to compute an area. For example, if you have a trapezoid and you transform it, you cut it out, and you end up with a rectangle, and that's how you get the height times base formula. So I made this several activities to see the different possibilities that you can exploit from paper. The first one is this multiple representation, for example, of different characteristics that you can have on quadrilaterals. For example, their lengths of sides, their angles, etc., and that the pupils can use to explore how quadrilaterals are classified. Another one was to use the protractor, because another good thing with paper is that you can actually use the real tools are they're supposed to be used, such as the protractor, the ruler, etc., because you can actually draw on paper as opposed to an iPad, for example, where it's more annoying to put some pen on it. Then I also showed how you can use a paper interface to make more game-based activity to use this protractor. So in this case, we had a scenario that shows the pupils that the protractor is not only about measuring angles, but you can actually use it to communicate something as abstract as an angle. The last activity I showed was about symmetries. So in this case, the pupils could draw on one side of a sheet, and on the other one, he could see what happens to what he is currently drawing. If it was drawn symmetrically, so we can see that if he goes up and down, it's also up and down. But if you go left, it goes right, and that if you write a letter, it's going to be like it's in a mirror. I'm not sure. So what I see that's interesting in paper interfaces is that they really have a lot of potential for education, which is the main topic of this conference, because so first, it's really easily integrated in the schools, because if you go into a school, you open the door of the classroom, and if you look at where is paper, you actually realize that there is paper everywhere. It's on the wall, on every poster, it's on the desk, it's inside the desks. It's even sometimes they hang a string to put more paper everywhere. So if you manage to put the computing power in paper, then you can finally use all this work that has been done on technology for learning, but that doesn't quite make it into classroom because it doesn't really fit. So in the best case, there are a few computers at the back of the classroom, but that's exactly what they are. They are in the back, a bit isolated. And I hope that I hope that I was able to show that there are really a big potential in paper interfaces, that you can use them in very different fields of research in technology, in education, and maybe that's what I like.